number series. Okay, basically you can understand a series of numbers are given. The series of numbers are given. In that, some numbers will be missing. Usually the last number will be missing, or in some cases the middle numbers will be missing, and there can be more than one missing number. There can be two, there can be three, but generally one or two will be there. Okay, we'll try to find out. And when I say series, mathematically it is a very particular word. When I say series, mathematically it is a particular thing. We cannot take random series and tell this is number series. No. So when we come across the number series, the first one is the arithmetic series or arithmetic progression. Arithmetic series or arithmetic progression. Geometric series or geometric progression. Harmonic series or harmonic progressions. Okay. Right now we'll focus only on these two. Harmonic progression, when I'll be telling you about time, speed and distance, I will take that. Why we have to use there. Understood? Okay. So kindly remind me about harmonic series or harmonic progression when I'll be dealing with time, speed and distance chapter. Okay. So right now we'll be concentrating on arithmetic series and arithmetic progression. When I say arithmetic progression or arithmetic series, basically the difference between consecutive elements or two consecutive entities, the difference what we'll get, it will be same. For example, 2, 4, 6, 8 and 10. What is the common difference? So these differences are nothing but the common difference. These differences are nothing but common difference. And how do we represent this? If you draw the chart, I had shown you 2, 4, 6, 8 can be drawn like this in a straight line. So arithmetic progression will always be in a straight line. And even this also I can call as a arithmetic progression. Even the decreasing order can be accommodated in the arithmetic series. For example, if you reverse this, 10, 8, 6, 4 and 2. This also an arithmetic progression. What is the common difference? Minus 2. Yeah, difference is 2, but it is in decreasing order. So minus 2. Okay, one element to another element, we have to subtract 2. Yeah. So both are called as the arithmetic progression. Simple. We are adding one common number every time. When we go from a number to the next, we are adding something. This is what is arithmetic progression. I think you know about this because this is one of the main chapters that we learn in our high school. Yes, you know arithmetic progression. All our multiplication tables are arithmetic progressions. 3 ones are 3, 3 twos are 6, 3 threes are 9. All these are arithmetic progression. And what is a geometric progression? What is a geometric progression? When you take something in series, from this to this, there should be a common ratio, or we are multiplying with something. We are multiplying with something. So I'll take that as a ratio. So there'll be a common ratio. We are multiplying with this thing. If I start with 2 and 4 now, we are multiplying with 2. So 2 twos are 4, then 4 twos are 8 twos are 16 twos are. So this is what? This is the geometric progression. Understand? So if you plot a graph for this 2, 4, 8, 16, 32. So it will be like suddenly raising. Suddenly raising. Understand? Okay. So slowly. So either it is something to the power of 2, maybe x square or x cube. X cube, it will raise even more exponentially. X to the power of 4, it will raise even more exponentially. Understand? Getting my point? Yes. So these are all geometric progressions. But in here, in particular geometric progression, we are just multiplying by 2. Or these are indirectly 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, like this. Fine. Is that okay? So arithmetic progression, we are adding something every time. And geometric progression, we are multiplying with something. And even the division thing also gets qualified into the geometric progression only. 32, 16, 8, 4, 2. What we are doing, we are halving. We are halving every time. So even this qualifies to be a geometric progression. Understand? These are the two things that we have to learn. But when we say this number series, we don't strictly deal with this arithmetic progression and geometric progression. Sometimes these number series can be illogical also. Can be illogical sometimes. I'll tell you on several occasions. And from an entity to entity, what we do know, either plus or minus or multiplication or division. This is not just with the maybe something you have to add and something you have to multiply, maybe to get this one. Add 2 and multiply 3. I cannot call that as an arithmetic progression, nor I can call that as a geometric progression. That is some nonsensical progression. But still, we deal such numbers under number series. So don't strictly sit with the arithmetic progression and the geometric progression, because in some cases, we have to deal with so many operations. Just you have to identify those operations. If these are strictly arithmetic progression and geometric progression, what you have to do? You have to check whether it is an arithmetic or a geometric. You will get the answer. But here, the tricks or the logics what they have used to get the next number, that can be like in a numerous manner, they might have arrived at that. Understand? More than one logic might have been applied. But we have to identify that logic. So this chapter, it is not purely arithmetic chapter. So it also includes some logical reasoning. Okay. And for you, there is a particular way of, like checking or particular way of finding it. I'll tell you what you have to do first whenever the number series is given, because you don't know whether it is arithmetic or geometric or something else. So I'll give you certain steps what you have to do first. If that is not applicable, then what you have to do next. And there are cases where you have to leave it to God. You tried everything, but you are not getting, and you have to leave that. And if you are getting the answer within 2-3 iterations, that is within a minute, if you are getting, you are lucky, and you have to mark that and proceed further. You should not sit with ego in these questions, because these questions have the capacity to ruin the entire paper. Looks very easy, but you are not getting. At that particular time, the logic is not flashing to you. Understood? So maybe you should not bet too much. 1 minute. Within 1 minute, if you are getting, that's okay. Otherwise, you are skipping this question and you are coming back to this question in the second or the third round. Understand? Some are very simple, some are very difficult. Understand? Okay. What we'll do, we'll directly look at the questions, and when the need arises, I'll tell you what exactly you have to try. So first and foremost thing, whenever you see the number series, you have to do one thing. You have to find the difference between two consecutive elements. That is the basic most thing that you have to do. If that is coming. After taking the differences also, if you are not getting the hint, maybe you are going for the second iterations. Whatever the differences you have got, no, you are finding the differences for those differences again. So finally, your number series will try to become a funnel. If there are 5 numbers, you will get 4 differences. If you are not getting a pattern there, you are going for one more level. So you'll get 3 differences, then 2 differences, finally 1. So basically you are what? Forming a funnel. But trust me, if the logic is right, within 2 to 3 iterations, you will get the answer. Okay? Within 2 to 3 iterations. And 50% of the problems can be solved like this. Just by finding the difference, not just in one step. Every step you are finding the difference and you will get the pattern. If not, then you have to take the ratio. Ratio in the sense, you have to multiply something to get the next. You have to multiply something to get the next number. Or even then it is not possible. Then you have to think of the mixture of few operations. Plus, minus, multiplication, division, like that. Square, cube, you have to think like that. Understand? So these are the number of iterations that we are doing, but we should give care that we are deciding within a minute. If it is consuming more than a minute, maybe we are skipping this question. Understand? Okay. We'll take one by one. 2, 6, 12, 20, 30, 42, and 56. All of them are increasing. I mean, like they are in increasing order. Yeah. So maybe if we add something to the previous, we'll get, or if we multiply something to the previous, we might get. But first and foremost thing that we have to do is find the difference. What is the difference? 4. You got the pattern? Yes. So what is the next difference that we have to add? Simplest problem. So 16 plus 16 is simplest. In one step only we are getting. But basically, when you go further, the difference is, basically the differences are in arithmetic progression. The difference between two consecutive elements, they are in arithmetic progression. Understood? But you don't have to go here. You got the clue here itself. Don't go for this step. Understand? Cool. This is the simplest problem, and such problems will never come. Okay? This is just to what? Ignite our engine. Just that. Then when it takes up the heat, we will go for the next level. 2, 12, 36, 80, and 150. Yes, they are in increasing order. They are in increasing order. But the quantum that is changing, by how many times it is changing, it is not that easy, like it is not simply add 10, it is increasing more. But for those things also, take the difference only. Maybe in 3 or 4 steps, you will get the answer. Okay. So what is the difference here? 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 Yes, they are also in increasing order. Yes, take the difference again. $26, huh? Yeah. Now, are you getting some clue here? 14, 20, 26. If that is not flashing, eat Mentos. Okay, if Mentos is not available, go to the next step. Okay, what is the difference here? So next, it has to be 6. And while writing, you have to be extra careful. If you add 6 to this, what will come? Now you have to add 32 to this to get this. 1 not? You have to add this to get this. What is that? 252. So how many iterations we have gone? We have gone 3 iterations. But trust me, 50% of the cases can be solved like this. Okay? 50% of the cases can be solved like this. Okay? Fine? Five, 16, 49, 104. Take the difference again. You got the clue? Yes. So next is what? So to add 77, so it will be 181. Fine. Life is simple so far. ಯಾರಾದ್ರೂ ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂದ್ರೆ ದಯವಿಟ್ಟು ಕೇಳಿ. ದಿಸ್ ದ ಸಿಂಪ್ಲೆಸ್ಟ್ ಥಿಂಗ್. ಓಕೆ, ಅದರಲ್ಲೂ ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂತಂದ್ರೆ ನೋ ಪ್ರಾಬ್ಲಮ್, ನೋ ಪ್ರಾಬ್ಲಮ್. ಓಕೆ, ಪ್ಲೀಸ್ ಆಸ್ಕ್. ಓಕೆ, ಯಾರು ಪಕ್ಕದವ್ರು ಏನು ಅನ್ನಲ್ಲ. ನಿಮ್ದು ರ್ಯಾಂಕ್ ಬರುತ್ತಲ್ಲ ಅವಾಗ, ಓ, ವಾಟ್ ಈಸ್ ದ ಡಿಫರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ಮೀ ಅಂಡ್ ದಟ್ ಫೆಲೋ? He used to do every doubt. Okay, he used to get everything clarified. Okay, that is why his concepts were very clear, and that is why that fellow cleared. Understand? What did I do? I sat with my ego, with my hesitation, and where I am, there only. So what you want, it has to be very clear. Sometimes at the cost of others, what? Peace also. You should be getting what you want. Because this world is like that. It is the competitive world. You should know what you want from others and you should get it. You should get it. Not by killing that person, but politely and diligently and authoritatively asking that person. Understood? Next. Here there is some locha. It is getting dipped. Dipped in the sense, it is getting lesser, then plus, then it is getting, and here it is same. How to do with that thing? So in such cases where there is a sine wave, think of the alternative numbers. Look at the alternative numbers. Sometimes two number series are mixed. Two number series are mixed. Okay, look at the alternative numbers. What is happening? Plus 3 every time. So what is the next number? 20. But if they ask another number here next, so that is the alternative number of this. What will be this number? If at all the second number is asked, 27, because every time plus 5. Okay, what is the answer here? 20. So whenever there is kind of a sine wave, something is increasing, decreasing, becoming equal, better you look at the alternative numbers. Can you call this as arithmetic series? No. No, never. Here it is the mixture of what? Two arithmetic series. Two arithmetic series. Now look at this. 4, 8, 16, 32, 64 makes sense. But alternatively we have negative numbers. So the simplest, 4 into 2, 8 into 2, 16 into 2, 32 into 2, 64 into 2, 128. But alternatively we have negative numbers. So answer is minus 128. And with this, like I had asked you to remember squares of first 25 numbers and cubes of first 12 numbers, no? So similarly, try to make a chart for 2 to the power of 1 to 2 to the power of 10. 2 to the power of 1 to 2 to the power of 10. And 3 to the power of 1 to 3 to the power of 6. Not more than that. 3 to the power of 1 to 3 to the power of 6. Okay. Then 5 to the power of 1, 2. 5 to the power of 5. 5 to the power of 1 to 5 to the power of 5. So 2 to the power of 1 to 2 to the power of 10, 3 to the power of 1 to 3 to the power of 6, 5 to the power of 1 to 5 to the power of 5. Try to remember these things. Okay, fine. Otherwise, I have told you to remember the cubes up to 12. So squares up to 25, cubes up to 12, and these exponentials. I think that will help you a lot. Rather than working them in the examination hall, if you remember them, it will save 5 seconds every time. Okay, fine.